Now in section 9, we're going to take a look at the function module page, which is identified as the function module 8 page in this section. And let's take a look at some of the data elements that are on this particular exhibit. The first paragraph illustrates the activity of labor reporting. Now, labor reporting can be done by different personnel both in and outside of the maintenance organization. In other words, we could have craft personnel clock in and out of maintenance work orders. Machine operators can clock in and out on maintenance work orders. There may be a reason that we would have, as an example, contract support through an outside contractor, and activities like preparation time, which is really the responsibility of the storeroom. They would likewise clock in and out on that first sequence or first operation called preparation time. So here we have to define where labor reporting is going to occur. And once we've established that, then we can next define how we're going to be able to pull this labor reporting data into the maintenance organization, and primarily to be reviewed by maintenance supervision and also by the maintenance work order planner and schedulers. The second paragraph addresses the maintenance work order to maintain company assets. And that's basically what we're doing relative to accumulating the costs. In other words, every work order that is issued, whether it's planned or unplanned, should have that work order costed out. And when we get into the next section, section number 10, we'll take a look at some of the financials relative to work order costing. The third paragraph establishes the ability, if it is in CMMS, to define the craft efficiency while on the job, and also craft utilization. And we do have in this section another formula which addresses the craft efficiency, and utilization is nothing more than summarizing all of the time elements by sequence or operation number that a craft person is spending on the job. And the last paragraph addresses the integration of maintenance work order planning and scheduling with not only the reporting activity, but also with the financial maintenance management function, which is module 9, if you remember, in our maintenance management program. So moving into the next two pages, which are the item master record data. Again, I'm not going to read all of the data elements here, but I want to address the top data element in this item master record. A, again, is the alpha designation. In the middle column identifies, in this case, the maintenance work order number. And again, we have the ability to develop a 8-digit alpha numeric work order number. So here again, this is user defined. We're providing you with all of the information, and it's up to you to pick and choose and develop your own, what I would call the master record layout as a byproduct of labor reporting. Now, moving into page number 1, we're addressing some of the data elements that maintenance supervision and maintenance planners and schedulers should consider relative to this function of maintenance work order reporting. Starting off at the top of the page, item number 1, we're talking about the work order number. See, I don't need the asset number and the location and so forth. The work order has all of that information recorded in it. Number 2, I want to be able to develop total time on the job, and I also want to develop the time on the job by major activity. Those major activities would be preparation time, travel time, which is both to and from the job site, the actual work time, and if you're utilizing the delay or contingency time, that would be fixed. But if I required more time than, let's say, the 5 or 10 minutes that you may have allocated, then we want to show the total elapsed time based upon that particular activity. Item 3, we want the clock number of the individual, or maybe the code numbers if we are in groups. We want to determine, item number 4, did we use all the spare parts? If not, then the unused parts would have to be returned to the storeroom. Likewise, item 5 is the special tooling, and 6 is the special equipment. Now, item 7 is the key to the labor reporting system. What are your observations and findings on the job? And of course, we also want to have the recommendations for operating improvement. Number 8, when you were on the job, was the job completed? Or was it partially completed, and should it be rescheduled for either the next shift or the next day? And item number 9 pertains to the return of spare parts, the special tooling, the equipment, and the special documentation that was originally issued out of the storeroom. We want all of these elements to be returned to the storeroom so we could close out the appropriate records. Now, item number 10, again, gives you the opportunity to develop additional user-defined data elements for maintenance work order reporting. Now, moving over to page number 2, we can now start to generate various reports as a byproduct of the reporting activities that we just had reviewed on page number 1. So we can actually define the actual preparation time, the actual travel time to the job site, the actual time on the job, the actual spare parts used, the observations and findings, and the recommendations for operating improvement, and the actual time that it takes to travel from the job site either to the next job or back to the maintenance department. Now, you'll notice that steps 1 through 7 are in succinct order. Those are the types of reports that we would get if the data from page number 1 was reported properly. Now, the other considerations, item 8, is the return of the various items such as unused spare parts, the tooling, and the equipment. And then we would return the work order to planning and scheduling, which is item number 9. And that work order would be reviewed by not only the planner scheduler, but by maintenance supervision. And then, as item 10 indicates, did we return any of the equipment, instructional material to the file? And that would be the data that was issued out relative to supporting a particular maintenance task. The exhibit that you are looking at right now is the data elements that we reviewed in the notebook in section 9, pages 1 and 2, which has to do with maintenance work order reporting. Now, what we are looking at on this particular screen format are some of the summarized data elements that were reviewed with you on pages 1 and 2. And this particular exhibit is in your notebook, referenced as page 2-1. We have the work order number, and then we have the actual prep time on the job, the actual travel time, and the actual time on the job, which I have referred to in the past as the work time or the wrench time. And we have the clock time of the craft person, the craft code, and then we have other data elements, and if you remembered, I said summarized, which pertains to unused spare parts, and were the tools and the equipment and the documentation that were issued, were they used, were they returned to the storeroom, were they proper? And then the most important data elements for this work order are the observations and findings and the recommendations by the various craft personnel that are working on this particular order. And when I talk about recommendations, you've heard me say this many, many times. The payback of good planning and scheduling is the recommendations by your craft personnel for operating improvement. Now again, you can have more data elements and more data for each one of these major reporting functions. You pick, choose, and design accordingly. Now, moving on to page number 3, we are now going to go through the steps of closing out the order. In other words, removing the order from open to close, and ultimately we can remove it from CMMS. We could return it in a file in CMMS. We could put it into a hard copy. We could put it into an aperture card or whatever type of retrieval you want to utilize. The first step is to remove the work order from scheduled to complete if it is complete. If it's not complete, we would have to reschedule the order, as I've indicated before. Now, step 3 is calculating the efficiency for prep time, the travel time, and the time on the job. Step 4 is to calculate the craft utilization, which is the total time on the job. Step 5 is to determine the actual spare parts used, and if spare parts were not used in total, then between the planner scheduler and the craft individual, we'd have to determine whether or not the spare part was put on the PM order incorrectly. Maybe we had too many of the spare part required, but these are things that you're going to get involved with as you refine the individual PM work orders as a byproduct of the actual execution and reporting against those work orders. You will also revise the schedule as required, which means you're going to take that work order off the schedule in its entirety. If, on the other hand, you may have to revise the work order data, that would be a step that would be accomplished by the planner and scheduler. And at the same time, the system will automatically revise the individual craft efficiency factor if you are recording and keeping track of those efficiency and utilization factors. Now what we want to do is to move to page number 4 and take a look at the formula for craft efficiency and the way utilization is calculated. And as the formula indicates, it's equal to the work order time. Now that's the estimated time that is on the work order, and this could be done by total time of the work order, and it can also be done by key functions of the work order, like preparation time, the travel times to and from, and the aggregate work time. So again, you have the ability to develop efficiency by total work order and by individual major functions within the work order. So that work order time is divided by the actual time on the job. And that's multiplied by 100, which would therefore give us the efficiency factor. Now you'll notice I used the term efficiency factor. In a previous illustration in section number 8, where we were talking about developing efficiencies, I used a 85% efficiency factor. That really is an inefficient factor. But because this is a rather sensitive area, as I talked about before, I recommend to companies that I have worked with and to students in my program, eliminate the word inefficiency and call it an efficiency factor. I think it's more palatable to people that you may be talking to, especially craft personnel. Now, the utilization, as described by the paragraph directly under the word utilization, is the actual time spent on an activity, and again, those are the 4 different major activities, or it could be the summation of all of the activities on a particular order, and it could likewise develop all of the utilization requirements by shift, by day, by week, and any other time period that you actually want to measure and monitor the utilization factor. Now you'll notice that there is a note on the bottom of page number 4 which indicates that we do have what I call a craft utilization coding system. It also can be referred to as a coding matrix, which is found on page 7. So we'll go to that page after we have an opportunity to walk through an efficiency and utilization example. This next exhibit that you are looking at represents the craft efficiency formula, and it also provides us with the ability to develop the total work order time, such as the work order estimated time, the actual time on the job. So what we're trying to do here is to develop the efficiency for the various activities, the various functions, such as preparation time, travel to and from the job site, and total work order time. We also can look at the total elapsed time on the job, which is in the bottom half of this particular screen format entitled Work Order Utilization. This would be a standard exhibit, a standard screen format that the planner scheduler or maintenance supervision would use for each time a work order was being reviewed and closed out. Craft efficiency and craft utilization, the 2 key data elements to be fed back to the planner scheduler to make changes to the original work order based upon sequences, based upon the time elements and any other data elements that would have to be changed as a byproduct of the reporting activity by craft personnel on a maintenance work order. Now, moving on to page number 5, which is also continued on page number 6, is this maintenance work order example. If you look at the top of page number 5, you'll notice that we have some work order time elements that are given. In other words, the preparation time is 15 minutes. The travel to and from the job site is 20 minutes. And the sum of all of the actual work time elements is 3 hours. Now, as a byproduct of the actual performance reported by a craft person, we get the following information. 1, the preparation time was 20 minutes. The total travel time was 25 minutes. And the actual time on the job was 3.5 hours. So if we look at the calculation of efficiency, utilizing the efficiency formula from the previous page number 4, we can calculate the efficiency for the preparation time, the travel time, and the actual work time. So let's take a look at the actual calculations for preparation time. 15 minutes of actual time in terms of estimated time. The actual time on a job is 20 minutes. So you could see we're operating at an efficiency factor of 75%. Likewise, taking the travel time, we had estimated 20 minutes. The actual was 25. So here, the efficiency factor is 80%. And again, looking at the actual work order time, the estimated time was 3 hours. It took 3 hours and 20 minutes. So the actual efficiency is 85.7%. Now, these are the efficiency requirements that would go into a labor efficiency and labor distribution reporting system. And again, let me repeat, if you do not want to utilize the efficiency factor because of its sensitivity to craft personnel, you can do the calculation, but as I said previously, you can keep the data within the system. And through proper security codes, only the planner scheduler and or the, let's say, supervisor of maintenance or craft supervisors are the only ones that can retrieve this type of information. Now, moving on to page number 6, we're going to look at the actual time on the job. Preparation time was 20 minutes, travel time is 25, and the actual work time was 3 hours and 30 minutes. So we summarize those 3 time elements, and therefore the total utilization time for this order was 4 hours and 15 minutes. Now that 4 hours and 15 minutes would go in to the utilization reporting system as from page number 5, we would put in the efficiency calculations under the efficiency reporting system. Now, as indicated on page number 7, we have our craft utilization coding system. These codes can be fixed within a reporting system, or they could be inputted by craft personnel based upon particular activities. The preparation time, 01, travel time, 02, the actual work time on the job, 03, and the contingency time, 04, would not have to be coded. We could fix those coding numbers right into the utilization reporting system. But where we get into other activities like training, 05, and waiting for spare parts, or waiting for special tools, or waiting for equipment, those codes, 06, 07, and 08, would pertain to lost time and could likewise affect the efficiency, if you will, of the preparation time for a work order. And the other time elements are self-explanatory. And down at the bottom we have XX, and it says others as required. And those are for your specific, requirements to add to this particular list additional utilization coding requirements. The exhibit that you are now looking at, which incidentally is also in your notebook, shown as page 7-1, originates from the craft utilization coding system, which is on page 7 of the notebook. And if you remember, as I went through the various code numbers and activities, I indicated that this is an exhibit that really should be tailored by supervision of maintenance and maybe top management in the organization to determine how the labor is being utilized in the maintenance organization. The sum of the payroll time should be equal to the sum of all of the time utilized by craft personnel. We recognize that some of the time is for cleanup time and rest periods and startup time. Those could be fixed within a labor utilization, or what some companies refer to as labor distribution reporting. The other data elements like prep, travel, and work on a job are an integral part of work order activities. Then the other activities from 05 training and down through the balance of the different codes and their activities that are shown on page 7 and likewise on this screen format are tailored to meet your own management reporting criteria. Now moving on to the next 2 pages, we are addressing some barcode applications that we have worked with other companies in the barcode environment. Many of these are standard in barcode applications, especially in CMMS, and others are designed uniquely for specific applications. Let's see if we can just walk through these to define any of these applications that require some additional information. Employee badge number 1, I think that's self-explanatory. 2, the maintenance work order. 3, the PM operation number or work order. You could have both. 4, the maintenance work order request. That's a request form. 5, the purchase order number. 6, the line number on a purchase order where you have 2 or more items on the purchase order. You could also develop identification tags through barcode application, which would address the 3 data elements that we've been talking about: the part number, the description, and the unit of measure. The bin location number in the crib is a standard, which is identified as 8. Item 9 is the crib number if there's more than 1 crib or more than 1 storeroom. Item number 10 is a little unique, and that's the cycle count form number. 11 is the maintenance work order schedule number. The schedule number would pertain to, let's say, a specific month plan, a month schedule. It could be done by day, or it could be done by shift or by week. The item number 12 is the tool identification tag, which would encompass both the part number and a description of the tool. And moving on to page number 9, item 13 would be the equipment identification tag. And here again, it would also address the part number and a description of the equipment. 14 is the craft employee code number, and 15 is the purchase requisition number. 16 would be the line number on the purchase requisition, and 17 would be the actual asset or equipment or machine tag that's found out in the shop, and 18 would be the machine operator instruction number, and that would be to support maintenance relative to the utilization of machine numbers. We would have the, by the support of machine operators. And 19 would be the machine operator number. Now where we would have projects, we would identify that through item 20 as project numbers. Then 21, we've addressed this in section 4, which is the two-bin or the bench stock form number. And 22, which would be the specific repair shop number that the two-bin or bench stock material is going to be housed in. 23 is an off-shift requisition number, and 24 would be those high security items which would be housed in a bonded crib within a storeroom. And then we would have 25 as special storage material for maintenance task numbers. And let me go back. 25 is special storage environmental tag numbers, and 26 would be special instructional material for maintenance work orders. Those would be issued out by the storeroom. And then again, 27 is addressing other barcode applications that you required. So you could see from pages 8 and 9, you have a tremendous opportunity to utilize barcoding to support maintenance management in CMMS. And now I want to address the reporting by maintenance craft personnel, and this reporting is accomplished on pages 10 and 11. Now page number 10 is addressing the major time elements in sequence that you would find on a maintenance work order. The data elements are below the bar or Gantt chart. In other words, P is preparation time, TT is travel time to the job site, W is the work time required, TF is travel from the job site, and then C is that contingency for delay. Now, before you turn to page 11, here is the key relative to labor reporting. And this is a maintenance supervisor's decision. Do you want to capture the total time on the job, excluding C, contingency for delay? Do you want to capture only the work time? Do you want to capture the work time plus the transit time? Now you see, you've got an opportunity to define the way you want labor reporting to be accomplished in the maintenance management program. So now if you would turn to page number 11, I have developed for you what I call a maintenance work order reporting matrix. The lower left-hand area indicates the type of work order reporting, and that is if I clock in on 1 and I can clock out on, let's say, 5, I would have total time on the job. If I clocked in on 1, 3, 4, and 5, I would have total time on the job less, if you will, the contingency for delay. And then the fourth method of reporting is clock in on 3 and out on 4. I would recommend that you use this reporting matrix, and every order can be reported independently of other orders. If there is considerable travel time, you may want to have reporting of in and out on travel. If there is a minimal travel time, like in small companies, then maybe all you want to do is clock in and out on the work time. Again, this is another illustration of user-defined. So we're giving you the data, we're giving you the tools in terms of how to utilize that data. Now it is up to you to develop with your craft personnel your specific reporting system. Now we can move into section number 10, which is the Financial Maintenance Management Reporting System. Now, in section 10, we're going to discuss the financial analysis of the maintenance management system. And if you look at the title page, which is the first page in this section, it is identified as Function Module 9. In other words, this is the 9th and last module within the maintenance management program. And as the individual paragraphs illustrate, this is the culmination of all of the maintenance activities to maintain the assets of the company in top operating condition. The first paragraph illustrates that this particular module is the financial reporting module. The second paragraph indicates that the reporting system is to be designed to meet all of management's requirements. That is both maintenance management and other management activities within the organization. And the third paragraph indicates that the financial maintenance management reporting system is designed to meet all company management reporting requirements relative to their specific needs. Well, that means that if management needs a report, they better define the data in the report and also the frequency of the report. Now, to get you started, since there are no item master records per se to speak of in this particular module, but we can talk about reporting of functions within this particular module. So the first item is the asset maintenance costs. In other words, what does it cost me to maintain each and every asset in the organization? Item 2 is inventory analysis. Now that's a very broad and general term. Here we can look at inventory turnover, we could look at inventory investment, we could look at the inventory reduction through vendor stocking programs and other related analyses. And these we are defining in this particular section. We have asset utilization, and that is how well are we utilizing our assets. As we indicated in maintenance work order planning and scheduling, we're trying to get the highest degree of utilization from our craft personnel, somewhere between, let's say, 80 to 85%, if not higher. when it comes to asset utilization, many companies are targeting asset utilization around 95 to 98%. And the only way you're going to accomplish that is through a well-designed and implemented maintenance management program. The fourth element is asset efficiency. How well is a machine or an asset performing? You know, I could have 100% utilization of an asset, but only produce 50% of the requirements based upon, let's say, the standard of production. So we need both asset utilization and asset efficiency to intelligently monitor and measure the productivity of assets. We also can measure the asset running time versus the downtime. And that is really a byproduct of maybe the shop floor reporting system. And my only comment here is we're going to have honest reporting from the shop floor reporting system if we're going to have true asset downtime versus running time analysis capability. We also want to measure all contractor expenses relative to maintaining assets. And then we get into craft utilization, craft efficiency, and the development of maintenance budgets. Now, these are just a few of many different applications relative to financial reporting. So let's turn to page number 1. And again, there are 2 pages that comprise these data elements. And some of these data elements relative to financial reporting we may have covered in the title page, but don't forget, here we're getting into more specifics. And the 2 key requirements now that you have to consider relative to these reports is number 1, the data contained in the report, and number 2, the frequency in which you want the report to be generated. So item number 1 pertains to maintenance department overhead by function. And a little later we do have an exhibit of overhead, that is maintenance overhead by function. Secondly, we want to have the craft payroll cost including overtime. And when we look at the utilization report, we can determine how well we're utilizing the payroll dollars. Item 3 is the maintenance spare part inventory costs. And here again, we can analyze this by individual part number. We could analyze this by, let's say, the family or the commodity code. And we could also analyze this by individual inventory classification code. Item 4 would be the cost associated with any special tooling. And when you set up a PM and a major minor overhaul, you may find that you may have to procure some additional tooling to support the entire maintenance planning and scheduling program. Likewise, is there any special equipment that would be required? Now, if you're going to install predictive maintenance applications, you probably are not going to purchase the equipment outright, but you will probably lease or rent the equipment with option to purchase. And item 7 is the craft utilization analysis. 8 is the craft efficiency. And again, utilization and efficiency can be done by individual. It could be done by entire craft, or it could be done by total, let's say, maintenance organization. Item 9 would be the maintenance costs by equipment or asset, and those costs generally would apply to the equipment or asset as a byproduct of the maintenance work order itself, or it could also include, as an example, contractor expenses and or machine operator costs. Again, it is user defined. Continuing on page number 2, we have item number 10, which is the equipment downtime versus the running time. Item 11 would be annual training costs for the entire maintenance organization, but those could be further defined, training for planning and scheduling, training for inventory management, purchasing management, also for the storeroom, and training for the various craft personnel and other types of training costs such as machine operator training and so forth. Then we would get into item 12, which would be special project costs, and 13 would be the different data processing costs. And when I say different, I'm talking the cost of hardware, I'm talking the cost of software, and to cost to upgrade, where upgrading is required in both software and hardware. And item number 14 would identify any additional types of financial analysis that you, from a maintenance supervisory standpoint, or other top management people in the organization would require. Now, continuing on with page number 3, we're addressing some financial maintenance accounts. And here again, we're not trying to make financial personnel out of the maintenance organization. We should understand what these particular accounts require, and in many cases we may need the support of the personnel in the financial department to help us to establish these accounts. One would be maintenance labor by craft. That could come right off of the payroll. We could also have inventory of spare parts. And here again, it could be by part number, by family or commodity code, or by individual inventory class code. We would have the inventory of special tools in item 3, the inventory of equipment in item 4, the supply items that are consumed by the maintenance department as 5. 6 would be contractor expenses. 7 would be the data processing costs. 8 would be the maintenance overhead by function. And 9 would be other costs such as training and other types of miscellaneous costs. Now, the key is to develop the data elements, which are the financial maintenance accounts, which are identified on 3. And as we start to generate the reporting system, then these reports would go into individual accounts, and it is the data in these individual accounts that would support the development of the reports that we've identified on pages 1 and 2. Now, moving on to page number 4, we have some additional expense accounts which are identified as 1, additions to capital, and that would include new equipment, improvement or replacements. 2, repair and maintenance expenses, including breakdown repair. B, routine inspection and preventive maintenance. C, upkeep such as painting. D, replacement from wear. And E, building repair. And also in E, we could include such things as, let's say, lawn maintenance and the maintenance of roads and sidewalks and any other things that would pertain to buildings and grounds. 3 would be dismantling expenses. And 4, the cost of providing and distributing utilities, including electricity, steam, water, and compressed air and other utility requirements. Item 5 would be miscellaneous expenses, to include such items as experimental work that is expensed off, equipment cleaning, janitorial services, trash removal, and all other services in maintenance not listed above. Item 6 would be the outside contractor expenses, and these costs, as you can see, are over and above some of the previous cost and expense accounts that we have listed in page number 3. So here is another opportunity to develop the user-defined requirements for maintenance department expense accounts. The data elements relative to maintenance department expense accounts that I just reviewed with you on page number 4 are covered by the following 4 expense account examples. These page numbers, which follow page 4, are entitled page numbers 4-1A, 4-1B, 4-2, and 4-6. These are 4 exhibits that I selected from page number 4 of the notebook, and the page numbers tie in uniquely with the numbers that appear to the left of the individual expense accounts themselves. So starting off with screen format, page 4-1A, the heading is entitled New Equipment / Asset Costs. Now this happens to be for asset number PRSS0273. It is an 8-ton hydraulic press. It is located in prep area grid H8, and it was purchased via purchase order number M9600837. Now the original purchase order costs were $183,495.71. The item was purchased through the new item notice number 823382. Now the rest of the data elements, from transportation cost to installation, the various training costs, the contractor cost, facilities engineering, and then down at the bottom you notice there were other costs, miscellaneous, of $836. The key exhibit that or the key point that I'm trying to develop with this exhibit is that we can identify the asset, we identify the purchase order number, the new item notice number, all of the associated cost by some very specific description, and then we could summarize the total new asset cost at the bottom of the report of $216,230.71. Now this is merely one format to demonstrate how new equipment cost can be utilized in the financial analysis of the CMMS program. Now turning to Exhibit 4-1B. Here we are going to look at equipment asset revision costs. And in this case, we have the asset number, the description, and its location. Now, since this is not a new item, but a change cost, we are tying that in with engineering change notice number 532727. And again, we show all of the various costs from facilities engineering through training cost. So this particular equipment went through an engineering change notice procedure. It was approved, and the expenditures were all recorded, which totaled to $24,110. This is another illustration for you to follow relative to defining the way you may want to have equipment/asset revision cost developed. Now, the next exhibit is the exhibit for maintenance cost by equipment asset number, and that is shown on page 4-2. You'll notice that we have the asset number and its description, and we also have the location. Now, there are some work order costs associated with this particular asset, and those are shown in the body entitled Maintenance Work Order Costs. There are 2 maintenance work orders. We also had outside contractor expenses, and we show the contractor's name, the purchase order numbers that were tied in with those specific contractor names, and the associated costs. Then we have the facility engineering costs, which are basically project costs. So here, rather than have a maintenance work order number, we have engineering project numbers and their associated costs. And then the last cost of other asset maintenance costs are miscellaneous cost of $382. So in this particular case, we have maintenance cost for the furnace, the main unit, of $11,217.96. Now remember, these are examples, they're illustrations. Hopefully these examples will provide the type of detail that you and your management may want to develop for your various financial records. Now, the last cost pertaining to page number 4 in the manual is found on page 4-6, and that pertains to maintenance contractor costs. You will also notice that these are year-to-date by asset number, so that you could spool off or print out or obtain any cost for any asset at any point in time. And you'll notice that we have the asset number ARCD 002. It's a secondary air conditioner, and it's located on the plant roof by grid B19. The first cost associated with this particular asset pertains to contractor costs. And we have the total purchase order costs, which is summarized by the purchase order number V8273776, and the detail that comprises the $53,928 is found in the body of the contractor expense account. Below that, we have another asset, which again is a HVAC penthouse number 9 element, and that is located on the plant roof, grid B19, right next to the air conditioner that we just reviewed above. Here again, we are contracting this particular maintenance requirement outside, and you'll notice that we have accumulated a total of $28,512. And then, if you so desire, and you wanted to have as an example the total costs for the air conditioner and the HVAC system, assuming that they are tied in some form of tandem operation, then we have a total cost of $82,440 for those two assets. Now, these four cost records or reports that we just reviewed are to get you started relative to some of the data elements and the summation of individual cost relative to developing maintenance cost by either asset and or the expenditure that was accomplished either internally or externally or a combination of the two. Now, moving on to page number 5, we have the listing that I made reference to before relative to maintenance department overhead by function. If you have a facilities engineering department, we only want the costs of the time that facilities engineers are used to support maintenance management, not in the design and development of new equipment, assets, or processes. Item 2 would be all of maintenance supervision. 3 is the inventory control or inventory management activity. 4 is the purchasing function. 5 is maintenance work order planning and scheduling. 6 is quality control, which would encompass the receiving inspection activity. 7 would be the other cost of stores and warehousing. 8 is the material handling cost, where we're actually transporting material from the storeroom to the job site. Any clerical activities that are associated within the entire maintenance organization, the data processing cost, and then other supplies. And last, item 12 would be others that are identified as overhead in your particular company. Now, this particular listing would be developed in dollars and cents, and it would be summarized into one total annual figure. And this annual figure would therefore be prorated against all of the labor hours that go into each and every maintenance work order. And therefore, we have the ability to charge the true maintenance cost against maintenance work orders. The spare parts, the labor, and the overhead. And I could tell you for the 34 or 35 years I've been in maintenance activities, very seldom do I see the overhead portion charged to the maintenance of assets. And I don't understand why. Because if I contracted that work out, in other words, if I eliminated my maintenance department, when I contract that work out, what do you think is in the contractor's costs? Only his spare parts and labor? No. He has his or her overhead in there plus the profit. So I encourage you, and along with your financial management people, to reconsider the way you are costing out your maintenance orders. I think you're doing an injustice where you leave overhead off. That is my personal opinion. Now, I've concluded the development of the various overhead accounts that you may want to consider in the maintenance department. And the exhibit that you are now looking at is in a notebook entitled page 5-1. And what we have done here is to provide you with the overhead cost by function for some specific maintenance support activities. Don't forget, these are non-craft activities. They're support activities which I refer to as overhead. We have the first one, which is plant engineering support, and that's $15,000. Now, that's a monthly cost. We have maintenance supervision of $13,000, and the planning and scheduling is $11,250. Inventory management of $2,450, and you can continue to read the balance of the individual monthly costs. And here we have a total overhead cost that is by month to support the maintenance department of $130,929. Now, as I indicated previously, the overhead costs should really be charged back to all work orders as a function of the percentage of actual craft labor being charged to a specific work order. The three costs, therefore, going into a work order would be all of the spare parts and other related material costs, all of the craft labor costs, and then as a percentage of the craft labor, we would have the maintenance overhead cost. Those three would truly represent the actual internal cost for a maintenance work order. Now, moving on to the next page in the maintenance work order costs, we have the cost that would include the labor, the spare parts, and any tooling or equipment that could be rented. And here we have item 5, the maintenance overhead. And if a work order was supported by contract expenses, we would show that. And item 7 would be any other cost associated with the maintenance work order. Generally, maintenance work orders would have item 1, the maintenance labor, item 2, the spare parts, and item 5, the maintenance overhead. The other costs are supplemental to those three costs. Now, we've just concluded looking at maintenance work order cost on page number 6. In order to put these into a CMMS program, I have provided you with 2 screen formats, and those are covered by page numbers 6-1 and 6-2 respectively. These costs are going to be shown on 2 separate screen formats. The first screen format identifies the work order, and this is for work order 50728, and the date of the work order is October 15th, 1996. We have the asset number, which is MTR 827, and it is a main drive motor. Now, what we have done here is to identify the different craft labor costs, and you could see we're talking about an electrician and a mechanic, which has a total labor cost of $141.24. Then we identify the different spare parts that we have used, and in this case the spare parts cost is $166.69, and as I indicated on the previous exhibit, we're now showing a maintenance overhead cost of $53.57, and in order to accomplish the maintenance activity against this particular main drive motor, we had to actually rent some special tooling and equipment, and those are shown respectively on this particular exhibit. Now, moving to the second screen format, And again, if you're following the screen format, likewise in a notebook, this would be page 6-2. And you'll notice that on the heading, we indicate that this is maintenance work order cost analysis, and it is a continuation of page number 6-1. We had some outside contractor assistance, and we show the contractor number and the name of the contractor along with the purchase order. And here we accumulated cost of $273.78. We likewise had to utilize 2 facilities engineers, and their total time and cost are recorded accordingly, which is a total of $139.87. And when we summarize the total maintenance work order cost for this particular asset, asset number MTR 827, we have a total maintenance work order cost of $1,001.80. Now this is a good indication for you to review again with other, let's say, maintenance management and other departmental personnel managers in the organization. Because here we're showing you maintenance labor cost, the spare parts cost, contractor cost, and likewise facility engineering cost for this maintenance work order number 50728. It's another illustration of how you can develop your individual maintenance work order costs and report those costs accordingly. Now, moving on to page number 7, we have a very comprehensive outline for the analysis of spare parts financial inventory reports. And we have, as I said, it's a very detailed listing, and rather than walk you through these, we've talked about many of these. They are self-explanatory, but let me address the 3 major ways to at least review the financial inventory account. First of all, we want to compare where we are today versus where we were a year ago relative to inventory investment. Remember, as we start to do more planning and scheduling, we develop more and more vendor stocking programs, the total inventory investment should decrease. How far can it decrease? It depends upon the ratio of planned versus unplanned work orders. I have seen in some instances go 80% reduction and more, and there are a couple publications that I have read that some companies have reduced their aggregate inventory in excess of 95%. Number 2, we can look at the analysis of inventory investment by not only part number, but by commodity code and also by inventory class code. We can also look at the turnover by part number, by family, commodity code, and or by inventory class code. And those to me are the very key reports that you may want to consider in the analysis of inventory investment. All of those items that are shown on page number 7 are really a byproduct of many of these reports that I have indicated. Now, we've just completed looking at 22 different financial inventory reports on page number 7. And in order to try and take some of these particular reports into a CMMS application, we have identified some of these particular inventory reports on this particular screen format, which likewise is in your notebook, identified as page 7-1. There are two sections to this particular report. The first section pertains to inventory class code 03. And in this case, we show total inventory on hand. We had no consignments in or out. We had inventory turnover analysis of $387. We had starting inventory of $186,372. We had purchases of $26,738, so therefore the ending inventory is equal to the total inventory for the first line in this particular illustration. Now the second inventory class code is class code number 14, and here again we have the total inventory on hand. That's our starting inventory. We had some inventory consigned in. We did issue material out, which is consigned out. We have inventory analysis, which is the turnover cost of $176. And we have starting inventory value of $173,827. And we have purchases, and therefore we have an ending inventory which is identical to the inventory on hand at the beginning of this particular analysis. This is merely two illustrations showing inventory analysis of two different inventory class codes. And if you went back to page number 7, you have an opportunity to develop additional inventory financial analyses for all of the inventory class codes. And if you remember, there are 18. You likewise can have inventory analysis by what we call inventory class by family or commodity code, which means that all motors are grouped in one commodity and so forth. And you could have just a myriad of different inventory financial analyses relative to meeting any of your top management requirements for inventory analysis. Now moving on to the next 3 pages, 8A, B, and C. These are some financial accounts that you may want to consider to be established for the storeroom. Item 1 is the inventory value of all storeroom or crib assets. 3, the inventory value of all commodities. See, I'm going back to that commodity and family code. Item 3, the inventory value of all classifications. 4, the inventory value of all special equipment. And 5, special tooling. 6 is the results of cycle counting. 7 is the inventory value of cycle counting errors. That could be done by, let's say, month and summarized by year to date and actually come out with an annual report. Number 8, the inventory value of inventory adjustments not as a result of cycle counting. And item 9 would be the inventory value of maintenance special equipment adjustments. That is where we'd actually have a loss of equipment. And continuing on in 8B, we have item 10, the inventory value of maintenance special tooling adjustments. And here again, that would pertain to a loss of tooling and where we actually had to replace it. And item 11 is the inventory value of facilities engineering projects. and that is what inventory was actually used and supported by the storeroom. Also, item 12, the transaction analysis that we've talked about earlier when we were in the storeroom program, and that is all of the receipts, the issues, and the location consolidation. And those transactions, if you remember, are the input into storeroom layout initially by family or commodity code. Then 13 would be all of the payroll accounts. That could be total payroll for the entire storeroom, and then we could separate that into functional requirements, like people that are in the receiving inspection, order filling, those that may support shipping, and likewise cycle counting on a full-time basis. In addition to that, we could have item 14, various inventory value of vendor consigned materials. 15 would be contractor consigned materials. And 16 is the inventory value of employee safety materials. And 17 would be the inventory value, and we could likewise develop inventory turnover analysis for shipping supply materials. And finally, on page 8C, item 18 would be the inventory analysis of shelf life items. In other words, how well is the shelf life program supporting the return of shelf life items as they are approaching, if you will, the shelf life date code. Item 19 is the inventory analysis of the obsolescence program, and 20 is the inventory value of scrap materials. Those are materials that cannot be used because of the physical nature, such as deterioration, non-functionality, and so forth. And also 21, the inventory value of all storeroom physical assets, which would include, as an example, the shelving cost, the equipment cost, and any cost relative to equipment, and any other cost associated to maintain the operating condition of the storeroom. And 22 indicates other financial accounts as required. Remember, user defined. Now, we have just concluded reviewing 9 different financial accounts for the maintenance storeroom or the crib on page 8A. What I want to do is to review with you 2 individual financial records, and those would pertain to item 4 and item 5 on page 8A. The screen format for item 4 on page 8A is headed by special equipment costs. Now, that exhibit is also in your notebook under page 8A-4, which ties in with item 4 of the outline. And here we have the total equipment value of $43,590. We have the commodity code, inventory value. We have new equipment purchases, which is the second group of cost data. We have repair costs. Then we have total equipment rental costs. And we have the total equipment replacement costs, and here they are all tied in with specific commodity codes. Now remember, these commodity codes are equipment commodity codes. They are not to be misconstrued as inventory commodity codes for spare parts. Now the second financial analysis for special tooling costs are found on page 8A-5, and we are now looking at that particular exhibit, and that is entitled Special Tooling Cost. Now here again, we're showing those by commodity code and their respective inventory value. So we're starting off with total tool inventory value, which is the first section of this particular tooling cost analysis. Then we add the new tool purchases, and again by commodity code and by purchase cost. And if you wanted to have the purchase order numbers and other data tied in, like the supplier and maybe the part number, if you will, of the new tool as opposed to the commodity code, you can tailor this to your own requirements. We also have and show the total repair costs, and then there are times that we have to rent equipment, so we have a rental cost, and then last but not least, we have total replacement costs. So out of the 9 individual storeroom financial accounts showed on page 8A, we selected items 4 and 5, and those are shown by the 2 exhibits that we reviewed with you. Now, what I would like to do is to cover 4 additional financial reports with you, and these were really not identified specifically in section 10 of the notebook, but it's an indication of what you can do with the input from other support personnel, whether they're in the maintenance operation or external to the maintenance operation, relative to the development of financial data. Remember one thing in CMMS. If the information is in the system, the information can be formatted based upon your requirement and can be put into a report based upon the data elements you so require. Again, let me repeat. If the data is in the system, you can extract the data based upon the way you would like to format that data. So let's look at this exhibit, which really is exhibit 9-1. It is in your notebook as page 9-1. And this represents the maintenance craft payroll costs, including overtime. Now, this exhibit has 2 sections to it. The top section pertains to payroll. The second section, the bottom half, pertains to overtime. So if your management wanted to see a summary of both payroll and overtime costs, then all you would have to do is to add up the subtotals of both payroll and overtime. In this case, we're showing them separate because many management personnel that I have had an opportunity to work with, that is management personnel outside of maintenance, are very much interested in the differences between the payroll cost and the overtime costs. Now, moving on to the next exhibit, which is in your notebook under page 9-2, we're showing craft utilization report. And this craft utilization report is for 2 specific crafts. One is for the electricians, and it shows that we have 160 hours available. So what we want to do is look at how well we have utilized the 160 hours of the cumulative available electrician's time. Another way to look at this is the 160 hours available could be equal to the craft capacity for those electricians. And you'll notice we indicate the number of labor hours reported. Now, if you want the detail of how those labor hours were accumulated, you would have to go into each individual work order and extract the times for preparation, the travel times to and from, and the actual work time. So in this case, we have utilized a total of 142 hours and 75, actually 142.75 hours. So our utilization percentage is equal to 89.22%. That doesn't appear to be too bad, but the name of the game, if you remember when we talked about work order planning and scheduling, we want to try and get that utilization as close to 100% as practical. Now for the mechanics, we have a total, again, of 160 available hours, and we have a total utilization of 72.03%. I would say that there needs to be some improvement with respect to our mechanical group. And down at the bottom of the summarization of these two, we show the total available hours summarizing the two groups, the total hours actually utilized, and the aggregate utilization of 80.63%. So you could see if the data is in the system, you can extract it based upon your user-defined requirements. Now the next exhibit, which is identified as Exhibit 9-3, pertains to craft efficiency. And here we're looking at 3 different employees. We have a mechanic, which is the first portion of the report. We have in the second portion another mechanic, and then in the third portion we have an electrician. And in these cases we're talking about the estimated hours of actual work, that is the estimated hours of actual work on the work order, and then we have the actual hours that have been reported. So you'll see that the first mechanic had taken 2 3/4 hours more than what he was actually scheduled for. In the second case, we actually took 8.25 hours more, and that's starting to show that our slippage, okay, is going negatively in the efficiency column. The third element is where we estimated 24 hours, and we actually did all of the work for 3 work orders in 23 1/4 hours. So in this case, even though we have brackets around that 3/4 of an hour, that really means we took less time than what we had scheduled. And that is what I've been kind of alluding to through this particular seminar. We want to get craft efficiency equal to or greater than 100%, and we want to develop our utilization up to as close to 100% as practical. So this particular exhibit illustrates the efficiency factor, where the the previous illustration showed the utilization factor for our craft personnel.